Velocity time graph example part 1. We learned before how to draw a velocity time graph. In this tutorial, we'll learn how to use it to get important information. For example, we can get the slope of velocity time graph, which gives us information about an object's acceleration. Now let's see the example in figure 1.1.8. We have here a velocity time graph showing acceleration, a steady velocity, and then negative acceleration. If you press on this button, here we have on the x-axis the time and the unit is seconds, and on the y-axis we have the velocity and the unit is meter per second. We notice that the first part has a positive acceleration and the object starts from rest. Then it has a steady velocity because it is a straight horizontal line. And then we have negative acceleration. Now let's start with the first part. The object accelerates from rest to 8 meters per second from 0 seconds to 4 seconds. So here we have u equals 0, or the initial velocity, and the final velocity v equals to 8 meters per second. And the time is equal to 4 seconds. Now we can get the acceleration by getting the slope. To calculate the slope, we can see that we have the height that is equal to 8 and the base that is equal to 4. The slope is equal to height over base. Or we can get the acceleration using the acceleration equation that is equal to change in velocity over time, which is equal to v minus u over t, equal to 8 minus 0 over 4 minus 0, and the final answer is 2 meters per second square. 4 here is time 2, and 0 is the time that the object started moving. Here we notice that the acceleration is uniform. Now let's start with the second part. We notice here that there is no change of velocity. That's why we can say that the acceleration is 0. And the third part, the object accelerates to rest from 9 seconds to 17 seconds. So time is equal to 17 minus 9, which is equal to 8 seconds. Or we can also get the slope using the equation slope equals height over base of the triangle. Here we have the initial velocity u equals to 8 seconds and the final velocity v equals to 0 seconds. Now if we use the equation of the acceleration, change in velocity over time, which is equal to v minus u over t, we get these numbers, 0 minus 8 over 17 minus 9, which is equal to minus 1 meter per second square. Here we have negative acceleration, or we call it deceleration.